I'm Miss Hanson, and today I'm going to talk to you about simplifying radical expressions. Now, it's important when we're simplifying radical expressions to remember the property that we use to multiply radical expressions. If the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b equals the nth root of ab. Okay? We're going to use that as we multiply. So first what we want to do is factor the expression under the radicand into perfect squares, cubes, or whatever's appropriate. So if it was the fourth root, we'd factor it into perfect fourths, or the fifth root into perfect fifths, okay? And then we're going to use the multiplication property backwards. We want to break it into parts. Instead of multiplying them together, we're going to work backwards. So we're going to take our product and work backwards to get the two parts. And then we're going to simplify, okay? So here's some examples. We want to simplify, and we're going to assume all variables are positive for these examples, so we don't need to worry about absolute value signs yet, okay? So here we have the square root of 75a squared b cubed. So first we want to factor the expression into perfect squares because it's a square root. So I've got 75, I know that's 25, or 5 squared, times 3, times a squared, and then b cubed is b squared times b, okay? So that's our first step. Now we're going to use the multiplication property to break this into parts. So the way that I'm going to break it into parts is on my first radical, I'm going to place anything that's a perfect square. So I've got 5 squared, a squared, and b squared. And whatever's not a perfect square is going to go in the second one. So I have 3b. Okay, now I can simplify by taking the square root of everything here. And remember, we're assuming all variables are positive, so I don't need to worry about absolute value yet. Square root of 5 squared is 5. Square root of a squared is a. Square root of b squared is b. And then in my second radical, I just have radical 3b. Okay? Let's try another example. Now this one is a cubed root. So we're going to simplify by changing everything or factoring everything into perfect cubes. So 24 I know is 8 times 3, and I know that 8 is 2 cubed. So I've got 2 cubed times 3 times x to the fourth is x cubed times x, and y to the sixth is just y squared cubed. Okay? So, oops. Now what I want to do is split this into 2 cubed roots. So I've got cubed root, and we want to put everything that is a perfect cube here and everything that isn't here. So 2 cubed goes here, 3 goes here, times x cubed goes in this first one, and x goes here, and then y squared quantity cubed goes in the first one. Okay? Now I'm just going to take the cubed root of everything under this first radical. The cubed root of 2 cubed is 2. The cubed root of x cubed is x. The cubed root of y squared quantity cubed is y squared, times the cubed root of 3x. Okay? So that's how you do problems of this type. The first thing you want to do is factor every term using whatever the radical is. If it's a square root, we're going to factor everything into perfect squares. And then we're going to use our multiplication property to separate the radical into 2 different radicals, one that contains all of our perfect squares and one that contains the numbers that are not squared. And then we're going to simplify by square rooting. Okay? So that's how we're going to simplify radical expressions. Have fun with these. I know you're going to have a good time and you're going to do great, and I'll see you next time.